Your change in your y values is f of x plus h minus f of x. And your change in your x values can just be represented by that distance h. So now we have y equals x squared minus 4. So we look at a picture of what's happening here. There's x squared minus 4. And at the point 3 comma 5, we want to find the slope of that tangent line. So it's going to be the limit as h goes to 0. And we have f of x plus h minus f of x. And our x value is 3. So using this formula, it's maybe a little bit more awkward with this part, the f of 3 plus h. Because what you're going to have to do is you're going to have to plug in the 3 plus h for the x. It gets squared minus 4. And again, I've done it the long way here. Right? You definitely could have just put 5 there because you were told at the point 3, you know that it has the point 3 comma 5. I wouldn't have to plug it in again to figure out that it's 5 again. Now the 3 plus h squared, you're going to have to FOIL that out. You've got 9 plus 6h plus h squared minus 4. And something beautiful happens. The 9 minus 4 is 5, and then you subtract 5. And the numbers go away, which allow you to factor out an h. And of course, this is true with any limit, right? This is our goal. That non-permissible value of dividing by 0, we want to go away. And now we can plug in 0 and get 6. And then to find the equation line, tangent line, you can either, you've got your point and your slope, you can either use y equals mx plus b and find b, or you can use y minus y1 equals mx minus x1. You don't have a formula sheet anymore, right? Right? You don't have a formula sheet anymore. So sometimes things like y equals mx plus b is like so drilled into your head, you don't have to remember that one. But what about this one? How do I remember this one? Your slope is change in y over change in x. That's y2 minus y1 over x2 minus x1. I think you know your slope formula. Can you see that if you just took this part, I want to circle in blue, this part and multiplied it over to this side, that's all this formula is. It's just your slope formula rearranged, and instead of a y2 and an x2, you're like, well, for the equation of the line, one of them needs to be an x and one of them needs to be a y. So that's all that formula is. And that can hopefully help you remember it better and think of it quickly. Anyways, whichever one you have, you're going to get y equals 6x minus 13 in the end. So again, limit as h goes to 0, and we're finding it when x is 6. So we would have f of 6 plus h minus f of 6. Of course, f of 6 will be 3. But I plug things in, substitute the 6 plus h in for the x, and I get square roots. Because this is going to be square root of 9 plus h minus 3 over h. How did we do these kind of limits? With square roots. We have to multiply by the conjugate. Absolutely. Now, when multiplying by the conjugate, and you've done a bunch of these already, okay? I want to get rid of that h. That's what's causing me problems. Because then when h goes to 0, that causes me to divide by 0. Okay? So in the bottom, I would leave it factored out and not multiply it out. Because I want to cancel out that h, so it makes sense to have that h factored out to make it easier to cancel out. But in the top, I will distribute everything on the top. And you'll see that the 9 minus 9 go nicely away. And then your h divided by h also go nicely away, leaving you with 1 over the square root of 9 plus 3. Square root of 9 plus h plus 3. Plug in 3, and you get 1/6. Okay? So if that's the slope of my tangent, my slope of my normal would be the negative reciprocal, so I flip my fraction and make it negative. My slope of my normal would be negative 6. And then you could use either formula to find your equation of your normal line. You have your slope, you have your point, and here's a picture of what's happening. This is the point. This would be the tangent line. Whoa, no, that's bad. Try it again. Here's the point. There we go. There's my tangent line. Perfectly at 90 degrees is my normal line.